Okay, we're moving right into our next unit, which is going to be about similarity. So we've talked about congruency so far, which basically means two shapes are the exact same, carbon copy. Yeah, one shape, all the sides are the same, all the angles are the same. Now we're talking about similar, so this is a little bit different. Polygons are similar, and as always, make sure you're starting your notes off nice and clean, copying this down. Polygons, which are just shapes, yeah, with multiple sides, yeah. Polygons are similar if all angles are congruent, which means they're the same, right? But all corresponding sides are proportional. So this is different than congruent. Proportional means that there is a scale factor from one shape to the other. Now, I briefly mentioned this, I believe, before fall break. When you're trying to size a picture, we talked about this with dilations, yes. Say you're trying to size a picture. You want everything to stay proportional, right? If you size it kind of the wrong way, sometimes your face gets all stretched out or you get stretched long ways, right? Proportional means it looks the exact same, just a smaller version or a bigger version, but all the proportions are in the same way as the original. You're not like super stretched out or super stretched wides. The proportions are the same. So mathematically, this means there is a scale factor going from one shape to the next. Now a scale factor, we got lots of new terms here, multiplies all the sides of a shape to get a new shape. So we have our original, we multiply all of the sides by some number. Sometimes that number can be a fraction, we got to keep that in mind. To get a new shape. We find this scale factor by, make sure you have this written down. What this means here, new shape over old shape. Eventually, I'm just going to say new over old. This means a side from the new shape divided by a side, the corresponding side, and I'll clarify this is very important. A corresponding side from the old shape, new over old. So for example here, we have two triangles. Now, we are going to say that these triangles are similar. Now, I meant to say this here. We have a new symbol. If I want to say triangle ABC is similar to triangle DEF, what we have is just a little squiggly line. Remember that congruent was that squiggly line with an equal sign underneath? This little squiggly line by itself means similar. So scale factor from ABC to DEF. What this means is this is the old shape. I'm going from here to the new shape. So to find the scale factor, I'm going to take a side from the new shape over a corresponding side from the old shape. Now notice we only have one shape or one side, so it's pretty obvious to see. However, it's very important to understand that looking at our statement here, I have AB, which is the first two letters, and this is DE, which is the first two letters. That's very important. That has to be true. We have to pick a corresponding side, which means the letters need to be in the same place in the statement. So my new shape is DEF. That's this one. So I'm going to put 10. And we can even write new by it if we want to. Old, so we don't forget. Divided by 5. Our scale factor is 10 divided by 5, which is, of course, 2. Now that should make sense, right? Going from 5 to 10, all I did was I took my old shape and multiplied it by 2 to get my big shape, yeah? And again, we do that to all of the sides. If we knew these other two sides, they would also get multiplied by 2 to keep the proportions the same, right? Again, we don't want it to get super stretched out or super stretched wide. Everything gets multiplied by the same scale factor. Okay, so lots of information up front, lots of new terms. Again, similar, proportional, scale factor. Make sure you have all that written down. Very important new terms. Let's go ahead and start off with this. Given these two trapezoids, now it says these are similar. It's really hard to see, but that's the similarity symbol. That's the little squiggly line. Now, we always want to, when we're given information, we want to take it and label it on our picture. So take a moment to copy this down, take these 3 pieces of information and label them on your picture. Okay, so WX is 8, HI is 6, HI is over here, And WZ was over here is 5. So this is all we have. Now, we want to find the scale factors to start. Now notice that I have 2 sides over here and only 1 side over here, as well as notice that these shapes are twisted, right? So obviously, we can hopefully see what the corresponding sides are, but this is how we know for certain. I only have HI right here. HI is the first 2 letters. I have to use that because I need 1 side from one shape and 1 side from the other shape. So I have to use HI. That means I have to use WX, which is this side. I have to use 1 side from one shape, 1 side from the other shape. So we actually do not need to know this 5 for this question for right now, because all we're trying to do is find the scale factor. We just need 1 side from one shape, 1 side to their shape. Now, here's how we know, though, which one is the new and which one is the old. We're trying to find the scale factor in 2 different situations. We're going from the left shape to the right shape. And then in the next question, we're going from the right to the left. So it's very important, it matters which one comes first, because the old is always first. The second is always the new one. Once again, our scale factor is going to be new over old. So I need the side from my new shape, which is going to be this one right here. I just labeled that HIJK is the new shape, and this is the old. So take a moment, think what number is going to go on top, what number is going to go on bottom if we want the new side on top and the old side on bottom. Okay, well, if this is my new shape, that means 6 is going to go on top and 8 is going to go on bottom. We can leave it like this, or we can get it as a decimal. I believe that's how they want it in your homework. So 6 divided by 8 is 0.75. That's our scale factor. What that means is to get from the old to the new, I would take all of my sides and multiply by 0.75. Again, this means that my old times 0.75 gives me my new. This was the old 8. This gives me the new of 6. So now we're going to try it going a different direction, though. Now we want this as my old, HIJK, and this as my new. So now again, let's be very careful with this. This is now the old, and this is now the new. My scale factor is still new over old. So take a moment. Now we're going in a different direction. So our scale factor is going to be different. What are we going to plug in here? What's our new side over our old side in this case now? It just flip-flops, right? Now it's 8 over 6. So again, get this as a decimal. Oops. This is going to be 1.33. We can round that to. So again, what this means is going from my old shape to my new shape, I would multiply by 1.33. Now, it's not going to give me exactly because we rounded, but that's the idea, yeah? So again, the difference is going from here to this shape versus here to here. It matters which direction you go. That's going to change your scale factor. So I want you guys to go ahead and try this one. Copy this one down a little bit. Be very mindful of this statement. This tells us what sides correspond to each other. Notice the shapes look like they're kind of turned. We have to pick the sides that go together. So take a moment, copy the picture, label the information, and then we're going to go from here. Okay, so we've got QR is 10, we've got QT is 6, and HI is 6. Now this one's a little bit different. This one does not say what's the scale factor. This one says find KH. That's our question mark. So when we have a question where we need to find a shape, find a side, we need to know what the scale factor is. Oh, no, we don't. That's why. No, that's fine. When we have a question like this where we need to find a side, what we're going to do is we are going to set up a proportion. Now, what a proportion is, it is two fractions that are equal to each other. So again, we are going to set up a proportion. Proportion. Two fractions that are going to be equal to each other. So what I'm going to do is I am going to So what I'm going to do is I'm going to create one fraction from one shape and one fraction from the other shape and set them equal to each other. If my shapes are proportional, these fractions should be the same thing. They're in the same proportion. So looking over here, now you have a lot of options, so you have to be very careful with this. It's hard to understand if you're doing it right because there's actually several ways you could set this up. So we have over here two sides. I am going to put them in a fraction. It doesn't necessarily matter the way I do it. I just have to make this one the same. Shoot. I might honestly just do this and that. Yeah, I think I will. It's going to get really long really quick.